1.2. Transformations of linear and absolute value functions. Exploration 1. Vertical translation, also known as vertical shift. Compare the function y equals absolute value of x plus k to its parent function, f of x equals the absolute value of x, or y equals absolute value of x. Y equals absolute value of x plus k is the parent function shifted k units up. It is up because it is plus k, up if plus k, down if minus k. Same shape, size and orientation as parent function. Exploration 2. Y equals absolute value of x minus h versus y equals absolute value of x. Because the minus h happens before the absolute value is applied, it is a horizontal translation, to the right if x minus h and to the left if x plus h. Exploration 3. Y equals the opposite of the absolute value of x versus y equals the absolute value of x. This is the parent function reflected across the x-axis or the line y equals 0. Reflections in x-axis or across the x-axis. F of x equals the opposite of g of x, where f of x and g of x are two different functions. Since f of x is the opposite of g of x, they have the same graph but reflected across the x-axis. For example, g of x equals x, f of x equals the opposite of x, which is the opposite of the other function g of x, so they are reflections of each other across x-axis. Another example, g of x equals x squared, which is the parabola that opens up, f of x equals the opposite of x squared, same shape and size but mirrored or reflected across x-axis. Reflections in or across the y-axis. F of x equals g of the opposite of x. F of x is the reflection of g of x across the y-axis. Given a function g of x, to reflect it across the y-axis, replace x with the opposite of x. For example, g of x is this parabola that opens to the right. To reflect g of x across the y-axis, replace x with the opposite of x. A reflection in the y-axis changes the sign of the input. X changes to the opposite of x, but the output is the same. Horizontal stretch and horizontal shrink. Given a function g of x, f of x equals g of a constant I times x is a horizontal stretch or a horizontal shrink. If a is between 0 and 1, it is a shrink if a is greater than 1. For example, the parent function of the quadratic family is y equals x squared. It is a parabola that opens up. The graph of the function y equals the quantity of 2 times squared is a parabola similar to the parent function, but it is stretched by a factor of 2 horizontally. A function can undergo a combination of transformations. For example, consider the parent function, f of x equals x. The graph of this function is a straight line that intersects the origin or the point 0, 0. To translate this function horizontally, for example, to the left h units, add plus h to the x. It is plus h because it is to the left, would be x minus h if it's to the right. The parent function shifts h units to the left is a new function, f of x equals x plus h. To translate this new function vertically up k units, for example, add a plus k to the entire function, then to reflect across y-axis, replace all inputs x with the opposite of x. To reflect in x-axis, make the entire function negative.